And now the judges have reviewed the submissions and we're ready to announce the winners of the 2023 Humanitarian Innovation Hackathon, the moment you've been waiting for. The Solar Robotics Prize for Best Use of Digital Technology, the winner is Let's look at their submission.
Vanuatu is a small island nation consisting of 83 breathtaking islands in the Pacific region. The majority of its population resides in rural communities where they depend heavily on natural water sources such as creeks and groundwater for their daily needs. However, given its geographical location and economic development, Vanuatu is one of the most vulnerable nations to the adverse impacts of weather events such as typhoons and floods. Beyond the visible demolition that these tempests create lies a more insidious threat: the vulnerability of drinking water infrastructure. Creeks and groundwater sources have sustained and nourished generations of Vanuatuan locals. However, as these tropical storms increase in frequency and severity due to climate change, these reliable sources of water and water infrastructure built around them are at serious risk of destruction and contamination. In order to address this problem, we propose an automated remote water quality data infrastructure that allows for real-time monitoring of the water quality near local groundwater pumps. We collect water quality data from many locations using a multi-parameter IoT sensor, which relays the data to a central management system. This data can then be used for a multitude of reasons, such as providing real-time updates on water quality after weather events and identifying high-risk regions that require water sources from the authorities. Our Water Quality Index tool provides information about several physical and biochemical parameters of the water, including the pH, turbidity, temperature, and total dissolved solid, and the pressure, all of which are used to determine the drinkability and availability of water at the ground pump. These sensor systems are relatively cheap given their utility.
In the last few years, rural communities in Vanuatu have experienced an exponential growth in mobile phone usage and network coverage to the point where they now have almost 320,000 mobile connections, which accounts for 103% of the total population. Our app takes advantage of existing mobile network infrastructure in order to provide live updates to the people of Vanuatu, assist governments as well as aid groups in decision making. This is a prototype of what a simple application interface could look like. It would have both offline and online capabilities so that when mobile networks are damaged by storms, you can still connect to sensors and obtain information about the water quality through Bluetooth connections to the sensor, which only switches on when the connection to the network is lost to preserve power. You can see it always displays the closest pumps with safe drinking water to you. Warnings are shown at the top of the page about changes to pumps nearby that you may have used. We've used a traffic light system to be intuitive and communicate clearly the drinkability of water. If you press on cards, you can see more information about a specific pump. These readings would be connected to a dashboard and back-end database that would be available to governments and community leaders to be more informed when making decisions on infrastructure development and adaptations. The diversity of the population means that it is essential we work with community leaders on the education of what these sensors do, which will also hopefully increase engagement and trust. This is our pilot program timeline. We plan to test on a smaller scale first to understand the feasibility of a larger network of sensors. Throughout the entire process, we would focus on building trust with the community, as it can be challenging since even a single instance of incorrect information can cause them to perceive the system as
Additionally, a novel technology from Geometrics utilizes 4-pole electrode cell measurement for capturing multi-parameter data, which can be integrated into our workflow. The sensor is placed in a pipe that can be easily inserted into the groundwater source in close proximity to the hand pump. In the long term, we aim to install these sensors across 60 council areas and educate locals on maintenance, operation, and implementation. Working with RED-R, we would be able to offer first-hand training to the locals on procedures of battery and sensor replacement. The sensor's robust and modular components reduce degradability and the need for frequent replacement. Moreover, opting for rechargeable batteries minimizes environmental impact. Over time, the data collected would allow for integration of solar panels to the sensors in low-risk areas of Vanuatu.
Sensor and data infrastructure allows us to extract real-time, data-driven insights for vulnerable regions in Vanuatu in response to floods or typhoons. It can also be used all year round to monitor water quality in accordance with SDG 6 and by extension SDG 3.
And third prize in the Humanitarian Innovation Hackathon 2023, the winner is the IT crowd. Angus Henderson, Franco Yama, Wesley Henderson from UTS and University of Sydney. Their mentor is Willa Butterman. Let's hear from the IT crowd.
Tonga faces a number of economic challenges due to its small size and geographic remoteness. In terms of its exposure and susceptibility to natural hazards and the unfolding effects of climate change, they are classified as the second most at-risk country in the world. This is most prominent in their transportation infrastructure, where roads and bridges are consistently being degraded through flooding and heavy rainfall. This infrastructure is vital for survival, as it is the only manner of commuting to the agricultural and fishing sectors that Tongans depend on for income. There are 680 kilometres of road making up the Tongan highway system, with only 184 kilometres of these highways being paved. This leaves a significant 72% of Tongan roads unpaved. These unpaved highways are the main method of vital transport for Tongans to commute to major cities and rural towns, with 85% of the Tongan population residing in rural areas. These roads are critical for trade and work, but being made of compact dirt are increasingly unable to handle storm surges and coastal flooding. The Tongan government has been spending a significant amount of money on road maintenance, 9.2% of their 2023 budget, a whopping $53.98 million. But being one of the most susceptible countries to climate change impacts, it is inevitable that these roads will deteriorate in the long term, costing the government further funding. Because of this, Tonga is forced into a cycle of short-term road fixes, using cheaper and substandard materials as opposed to more expensive, longer-term solutions.
Our innovation is called HOCO, a sustainably sourced lattice grid. It utilizes the climate-resilient qualities of plants to help minimize the effects of rising sea levels and coastal flooding on rural roads. Lattice structures are proven to be an excellent choice for applications where stiffness is required to be as high as possible for a given mass. This means that under continual heavy traffic, up to 500 megatons, the HOCO retains its integrity. In turn, this reduces soil compaction, leading to greater soil porosity and increased drainage capacity. The porous ventilation of the HOCO eases the pressure on road water absorption, making it resilient to road erosion. Filling each pocket with mud and plants creates a green infrastructure that mimics hydrological processes. Therefore, the heavy rainfall becomes a resource instead of a waste. This increased uptake of moisture from the soil is gradually released into groundwater and the atmosphere via evapotranspiration, hence preventing runoff otherwise produced by traditional impervious roads. This improves the efficiency of clearing puddles or pools of water, allowing for faster access of roads after extreme weather conditions. Additionally, the HOCO can be placed on the sides of roads, paired with reeds or rushes such as the native kuta reed, to resist large flows of water. This helps reduce the risk of large-scale flooding over roads, but also allows droplets to hit plant matter instead of soil, minimizing the amount of divots and road erosion that is common across Tongan highways.
The forestry industry in Tonga is a vital sector for many rural communities because of the abundance of coconut plantations. To utilise this, we propose the HOCO be made out of coconut timber. Small, portable sawmills have proved useful assets for small island groups without sufficient resources. They produce excellent timber at a price lower than imported timber. As a result, coconut timber becomes a locally sourced, affordable and sustainable material for HOCO production. Yet even reinforced plastics could be used to create the lattice grids, such as milk crates. Secondly, to build on the affordability of locally sourced materials, a native seed mix full of perennial grasses that have a shallow, fibrous root system is a best fit for green growth in the HOCO. The local kuta reeds and native grasses such as Leporus repens and Spirobolus virginicus are all perfect examples of plants grown in the HOCO. By using renewable materials, we support a circular economy, generating end-to-end raw material sourcing through manufacturing, implementation, and reuse, all integrated within our technology. A rough estimation based on the cost of coconut logs in Fiji currently approximates $6 per log of timber and grass seeds at $10 per kilogram, estimating a cost to produce a single HOCO grid at 10 US cents, significantly cheaper for the government, but also for the 23% of Tongan households that are estimated to be living below the basic needs poverty line at $28.18 per person per week. Hocko grids offer increased job accessibility, empowering individuals traditionally left without work due to disabilities or pregnancy, as minimal expertise is required. This inclusive approach fosters a sense of community while embracing Tonga's agricultural heritage. Moreover, Hocko grid's integration within natural ecosystems leaves no room for expansion and contraction of concrete roads, thereby avoiding future cracks, requiring little maintenance, resulting in cost-effective and sustainable construction techniques. The highly absorptive and rigid nature of the Hocko grids offers a highly effective, affordable and sustainable solution for safeguarding Tongan communities from floods caused by heavy seasonal rainfall and rising sea levels. Thank you.
And second prize in the Humanitarian Innovation Hackathon 2023, the winner is Team Nucleus, Elvira Abdel-Masih from UTS, and Jihan Chen from University of Sydney. Their mentor is Harshitha Rajashekara. Let's hear from Team Nucleus.
Our world is currently experiencing a critical problem: climate change. With extreme weather events on the rise, South Asia was 30 times more likely to be hit with heat waves due to human-induced global warming. Our most vulnerable communities bear the brunt of this crisis. In the informal rural settlements of the Asia-Pacific, the dangers of the situation are heightened by closely packed, high-density houses with limited windows that result in poor ventilation. The use of inferior materials such as corrugated iron and plywood have inadequate insulation and cannot regulate indoor temperatures, which can rise to over 40 degrees. This is not only uncomfortable but dangerous, where it is estimated that over 50 hospitalizations occurred over the 2023 heatwave, risking slums of dehydration, heat stroke, and long-term health problems.
Hey, we're Cindy and Elvira.
For us to lower internal temperatures without the use of electricity, we need to focus on passive cooling. With the compactness of slums, we chose to focus on insulating the roof.
After researching and consulting with mentors, we have created and refined our solution.
Introducing SunShield.
SunShield is a multi-layered thermo-resistant roof covering designed to protect and insulate houses, significantly reducing interior temperatures. Inspired by MIT's ISO technology, we present our adapted insulating solution for slums where costly materials are replaced with affordable, locally sourced alternatives. SunShield utilizes a unique 3-layered approach to deliver thermal resistance.
ISO uses aerogel as the top layer, made of 95% air, which has low thermal conductivity, meaning that it's difficult for heat to pass through, thus exhibiting exceptional insulating properties. However, aerogel is costly, so we opted to use locally available and lightweight coconut husks. The fibrous nature of the coconut husks create a highly porous structure, ensuring that the majority of the layer remains air-filled. During heat waves, the trapped air acts as an effective thermal insulator, while enabling radiative cooling, making it an ideal choice for the top layer. Also, coconut husk has fast drying and heat-resistant properties to ensure the system's durability and efficiency. The second layer protects against infrared radiation from the sun. ISO uses hydrogel, which we replace with coconut coir, a natural alternative. Coconut coir retains up to 9 times their weight in water and can gradually evaporate, carrying away the heat. Replenishing the coir with water is simple, either splashing the roof or from rain, making water the only resource the SunShield constantly uses. The final layer is a white paint base, which has high albedo, effectively reflecting sunlight back to the above layers. All 3 layers are enclosed within a cotton tarp, which we conveniently segmented into 2 separate layers for easy replacement where necessary.
Coconut is our primary material for SunShield and is readily available across the Asia-Pacific region. The coconut husk and coir are typically considered waste products, which we have repurposed to significantly reduce production costs. The supply of cotton tarp is the primary expenditure, but fortunately, cotton is locally farmed, thus manufacturing the tarp becomes a cost-effective endeavor.
Our innovative 3-layer approach effectively addresses all aspects of heat waves, from hot air to infrared radiation. This cools down the roof of the house, which in turn extends and cools down the wall of the house as well.
The effectiveness of SunShield is proved by ISA, who were able to drop internal temperatures by almost 10 degrees. Though we attempted to emulate the structure and properties of ISA's design, the result of SunShield may be less effective due to alternative, lower quality materials and conditions. The construction itself is fast and can be locally completed, which means that the implementation of SunShield can begin almost instantly. The adaptable design can be reviewed by local communities and councils to source cheap and local materials to manufacture SunShield. SunShield is highly portable and can be easily hooked onto the house's side and then rolled over the roof. It is easy to roll up, it allows anyone in the community to use it, and the ability to quickly unhook and pack up facilitates effortless transport, which is crucial during urgent evictions in slums and can lower fire risk and spread. Some maintenance of SunShield is required, primarily the replacement of husk and coil, which degrades after extended use. We predict that the husk and coil will need to be changed every 3 months, but this heavily depends on the conditions of use and more data needs to be collected after implementation. The husk and coil can be replaced separately if required. Also, any ribs in the tub will need to be sewed together or replaced. Overall, this low-cost nature and easily replaceable materials make SunShield a sustainable strategy.
Core of SunShield's innovation is bridging the technological gap between developed and developing regions, with a focus on delivering practical, affordable, and sustainable solutions to the most vulnerable communities in the Asian Pacific.
By translating high-tech equipment and cutting-edge research into actionable measures that integrate adaptation to specific communities, SunShield becomes a game-changer in the fight against the problems brought by rapid climate change.
In first prize for the Humanitarian Innovation Hackathon, the winner is Team Heat Block. This team is Adam Slimming, Alex Hoffman, Gemma Beeson, Sam Hillcoat. This is a mixed team from University of Adelaide and Monash University. They were mentored by Eleanor Earle. Let's hear from Team Heat Block.
As global temperatures soar, urban areas bear the brunt of extreme heat, intensified by the density of housing and heat-absorbing infrastructure. Nowhere is this crisis felt more acutely than in the vast informal settlements scattered across many cities in the Asia-Pacific region.
Informal settlements, characterised by haphazard construction and a lack of formal building conditions and land ownerships, are home to lower-income households who have migrated from rural areas in search of work.
During heatwaves, the vulnerability of informal communities reaches its peak, with negative health consequences exacerbated by the inadequate housing conditions and scarcity of drinking water and electricity. The challenges faced by these communities during heatwaves are further amplified by characteristics of informal urban housing, including high-density living, usage of cheaper and easily sourced materials, as well as limited access to running water and electricity, all things that contribute to climate change resilient housing.
We here at HeatBlock have come up with an innovative implementation to reduce heat gain in informal housing. Up to 35% of heat in a house is gained through direct radiation and heat transfer through the roof.
Introducing Cool Roof, a double roof system that is locally accessible across the informal housing situation of the Asia-Pacific region. Building upon the existing sheet metal roof, we have developed a cheap, lightweight, and environmentally friendly method of providing a second skin that reduces direct contact with the sun. Requiring the use of no power tools or fancy equipment, the entire Cool Roof is made of one ingredient: bamboo.
The Asia and Pacific regions account for about 80% of bamboo forests and species available worldwide. Bamboo is a highly sustainable resource due to its rapid growth rate and ability to regenerate after being harvested, making it an ideal material for eco-friendly buildings.
Our design is super simple, relying on existing local building techniques to quickly create a portable structure applicable across a variety of roof types. The design centres around 2 interlocking bamboo sheets, which are then bolted into place on a bamboo frame attached to the existing roof, thereby allowing free airflow between the layers. By relying on the natural strength and rigidity of bamboo, the roof is extremely lightweight but incredibly strong.
A double roof is made up of 2 separate roofing layers with an air gap in between. This air gap creates an insulative barrier between layers, reducing the heat transfer into the building through ventilation and air movement. Studies have shown that a double roof system can reduce heat transfer by up to 50%.
With just a single sharp knife or machete, you can effortlessly cut the bamboo, strip away its branches, and neatly slice it down the middle.
The sliced bamboo planks will then be laid out side by side and woven together with bamboo fibres. The beauty of this design lies in its practicality. Each layer can be easily rolled up.
In our innovative design, we incorporate 2 layers of split bamboo.
To provide ample ventilation and maintain a cool interior, the bamboo roof sections will be firmly supported by bolting them to 3 separate lengths of bamboo connected to the lower roof. So roll up your sleeves and roll out a cool roof, easy, quickly and affordably.
Our solution directly addresses multiple facets of the UN Sustainable Development Goals, particularly by improving urban housing sustainability with increased resilience to natural disasters and extreme weather events.
Through the ingenious application of a double roof concept, we can revolutionise housing and communities. By creating cooler homes, we empower these communities to build resilience against heat.
The Cool Roof design is extremely scalable across the entire Asia-Pacific region. Built from a widely available product using known manufacturing techniques, we have devised a simple 2-step plan to implement our innovative solution. Step 1 is to start small, targeting the informal housing communities directly. We will actively engage with local artisans to source and create the cool roof design in time for the upcoming summer period.
Step 2 is to grow big. We have created simple tutorial infographics for the dissemination into the wider region. These focus on educating the local populations about the long-term benefits of the double roof system, along with a helpful guide on how to create our simple structure for their existing roof type.
While we are unable to build every cool roof in the world ourselves, by releasing our open source design, we are allowing locals to seize the initiative and bring our process into their communities.
The beauty of the cool roof product lifecycle lies in its zero waste end goal. Bamboo sheeting has countless purposes for use in infrastructure, and even once the bamboo has finally degraded to have no structural purpose, it retains an important use once burned, providing heat and warmth as required.
Harvested from a fast-growing natural resource, easily and quickly constructed, and finding use until its natural biodegradable end, the design is centered on a continual community infrastructure building, creating a sustainable industry with impactful heat reduction effects.
While double roofing is a simple, well-known concept, it's just not used widely enough throughout the world.
Double roofs don't have to be technologically fancy to provide a tangible impact of heat reduction in the home. All you need is a machete, bamboo, and a willingness to improve the living standards of your local community.
The cool roof design will educate on the importance of passive, environmentally friendly infrastructure as global warming continues to disproportionately affect those in informal housing in developing countries across the Asia-Pacific region. A double roof is a cool roof.
Congratulations to all our winners this year. We had a great time with Humanitarian Innovation Hackathon. Good luck with your studies and hope to see you next year.